Well, welcome back. Today we're going to talk about the Pythagorean theorem, and I know most of you are already familiar with this. The Pythagorean theorem applies to right triangles, and a right triangle is a triangle that has a right angle. Okay, so just a few definitions to get out of the way. That right angle is always opposite the longest side, and that longest side is called the hypotenuse. The other two sides of the triangle are called legs. Okay, so the two shorter sides are called the legs. The longest side is the hypotenuse, and the hypotenuse is always opposite the right angle. So we have a specific relationship to find the lengths of any of those sides, and that's called the Pythagorean theorem. In any right triangle, the square of the hypotenuse, c squared, is equal to the sum of the squares of the other two legs, a squared plus b squared. Okay, so the longest one squared equals a squared plus b squared, the square of the other two legs added together. Well, let's go ahead and use that to find some lengths of sides of triangles. Our directions say write an equation that you could use to find the length of the missing side of each triangle, then find the missing length round to the nearest tenth. So in this first example, we're looking for the hypotenuse, so our equation is c squared equals a squared plus b squared. And then we're going to substitute in 12 and 9 for a and b. So we get c squared equals 9 squared plus 12 squared. Well, 9 squared is 81, 12 squared is 144. Add those two numbers together and you get c squared equals 225. Now remember, to solve an equation when we have a square, we need to take the square root of both sides. So the square root of c squared is c, and the square root of 225 is plus and minus 225, square root of 225. But it doesn't make any sense to have a negative length. So we're only going to use the positive value, so c would equal positive 15 in this case, because it wouldn't make any sense to have a negative length. All right, let's take a look at the next example. This one, we have the hypotenuse, but we're looking for a leg. Okay, same equation, a squared plus b squared equals c squared, but this time we will be looking for b squared. Okay, and it doesn't matter whether you would have called it a or b. Okay, so substitute in what you know. A is 8, c is 24. 8 squared is 64 plus b squared equals 24 squared, which is 576. Now how do we get b squared by itself? 64 is being added to b squared, so we need to subtract 64 from both sides. So we have 64 minus 64 plus b squared equals 576 minus 64. Remember, we're just subtracting that from both sides. Well, on the left side, these will add to 0 then, right? We'll get b squared by itself. And 576 minus 64 gives us 512. Now take the square root of both sides, and the square root of 512 is 22.6. And again, we're only going to use the positive value because the negative value doesn't make sense in this specific case. Here's a chance for you to try this on your own. Go ahead and solve for the unknown side in A, B, and C, and I'll give you the answers when you come back. All right, for this slide, I'm just going to go ahead and run through the answers. Let's see if you got those right. C squared equals 18 squared plus 24 squared. When you solve that, you should end up with C equal to 30. Letter B, your equation will be 3 squared plus b squared equals 8 squared. When you solve that for b, you end up getting 7.4 miles. And letter C, we are looking for a this time. So you have a squared plus 17 squared equals 20 squared. Solving that for a gives you 10.5. Now if you have any questions or if you got any of those wrong, be sure to ask me in class tomorrow. So the converse of the Pythagorean theorem says that if the sides follow the Pythagorean theorem, then the triangle is a right triangle. Okay, so the Pythagorean theorem says if it's a right triangle, then the sides follow the formula. So this one's the converse, it's backwards. So we're going to go ahead and use the converse of the Pythagorean theorem to determine whether or not something has a right angle, or whether it's a right triangle. Here's an example. It says the measures of three sides of a triangle are 5, 12, and 13. Determine whether the triangle is a right triangle. Well, if it's a right triangle, it will follow the formula. So let's put the numbers in. Now the main thing to make sure that you're aware of when you plug the numbers in is the biggest number, which in this case is 13, that has to go where C is. Remember that hypotenuse is the longest one, and it won't work if you don't recognize that. So go ahead and plug in your numbers. 13 squared equals 5 squared plus 12 squared. And it doesn't matter whether you assigned the 5 to the B and the 12 to the A, it'll be the same thing. So those are arbitrary. So go ahead and work that out. 13 squared is 169, 5 squared is 25, and 12 squared is 144. And that's our question mark. Is this equal? Well, 25 plus 144 is 169. They are equal. It does check. Therefore, it is a right triangle. Check out these two examples. See if they follow the Pythagorean theorem to determine whether or not they are right triangles. I'll give you the answers when you get back. All right, I hope you had a chance to try those. Check it out. Letter E. I hope I don't have these reversed. Letter D is, yes it is, 36 squared plus 48 squared is equal to 60 squared. Letter E, there's no answer there. Looks like we're going to have to do this one together. What's the longest side? It's 7, right? So is 7 squared equal to 4 squared plus 5 squared? Question mark. Well, what's 7 squared? That's 49. Is that equal to, question mark, 16 plus 25? What is 16 plus 25? Well, that one looks like it's 41. Is that equal to 49? And I do not think so. No, it is not a triangle. Excuse me, a right triangle. All right, here's your chance for check your understanding on this lesson. Go ahead and work on these 7 problems and bring your answers to class with you tomorrow, and we'll see you then.